For this section, we are going to integrate. And so the last two problems on the last section were how to differentiate inverse trig functions. Now we're going to integrate inverse trig functions, which means we're going to find a specific format. And these are your three options. And when we integrate them, they will turn into inverse trig functions. So you'll notice we've got arcsine, arctangent, and arcsecant for our options. Okay, they're not restricted to that because we could do this one and have arccotangent, that type of stuff. So there's other ways to manipulate this mess. But I'm telling you flat out that we're going to concentrate on these three. So the first thing I'm going to do, and I'm going to beat this first one to death, is I've got the integral of 1 dx. Please silence your cell phones during class. Okay, so I've got the integral of 1 dx over the square root of x squared. Hang on, let me turn this off. On. Never mind. I think it just died. My phone's dead. All right, so the derivative of the bottom is 1/2 2 minus x squared raised to the negative 1/2 times the derivative of the inside, blah, blah, blah. The derivative of the bottom is not in the top. So you'll remember a couple sections ago, as soon as I saw a fraction or a ratio, I immediately checked to see if the derivative of the bottom is in the top. It is not. I cannot use power rule because the derivative of the inside is a negative 2x, and I cannot balance with x's. Okay, I could balance the negative 2, but I cannot balance with x's. So the next thing that you're going to want to look for is going to be one of these three formats. So notice if there's no square root, you probably want to drift towards arctangent. If there is a square root, you got to differentiate, no pun intended, between a squared minus u squared, which is your constant squared, minus u squared, or your variable squared minus your constant squared. Okay, so that's going to be the difference between these two things. So just, what do I have first? In this case, I have a 2, which is my constant. So I'm going to try and see if I can force arcsine to work. So for this particular setup, what I'm going to do on every single one of these is I'm going to find out what is my u squared, what is my u, and then what is my du. And that right there is going to tell me if I have to balance anything. And then what is my a squared, and what is my a. Okay, so your u squared and your a squared are going to come off of this. So in this particular case, I would like to know what my a squared is. Well, what's sitting in its spot? There's a 2. Okay, what is my u squared? My u squared is an x squared. And now just drop everything down. So if u squared is x squared, then u must be x. Du must be 1 dx. And if a squared is 2, then a must be root 2. Okay, so since you already have the 1 dx, you don't need to balance anything. So this is just a straight substitution into the formula sheet. So what do we have? If that format is satisfied, which it is, then the integral becomes the arcsine of u over a plus c. So there's your u over a, which is x over root 2 plus big C. And that's it. So the hardest part in this section, and remember, you're supposed to be tracking through this the whole time. Can I use power rule? No. Is the derivative of the bottom in the top? No. Can I force this balancing thing to happen? No. So in my head, once I determine that stuff, I look and see if I've got square roots, which I will, or if I've got the sum of squares, which I'm fixing to have, okay? And then I can see if it'll morph into an inverse trig function. So the next one says I have the integral of 24 over 1 plus 36x squared dx. So remember, 24's job can either be a constant multiple, so I can drag him out front and change this into a 1, but I may or may not need him. Okay, so I notice that this is addition. And I also notice that there is no, what's the word? There's no radical. Okay, the derivative of the bottom is not in the top because I would need an x. There's not an x up there. Okay, so I'm going to see if I can morph this into arctangent. Remember, addition doesn't matter. So I could have my a squared plus my u squared, or my u squared plus my a squared. I don't care, as long as I've got the sum of squares in my denominator, which I do. So I'm going to set up my little format that I did up here. I got a u squared and a u and a du, and I got an a squared and an a. So if I'm going to match this up, what's my u squared? My u squared is a 36, x squared, and my a squared is 1. Okay? Everything else you just drop down. So what's your u? Well, what's the square root of this? It's a 6x. And then your du is a 6dx. And then if a squared is 1, then a is also 1 because you took the square root of both sides. Okay, I've got a 24. I need a 6. So you can approach this one of two ways. I can pull this 24 out front and then say I need a 6, so balance with a 6. Well, what does that lead turn out to be? That turns into a 4. So if you'd noticed, you could have broken down 24 into the 4 outside and the 6 inside. Either way, you're going to get the same answer. So this thing now becomes 4 times the integral of 6dx over 1 plus 36x squared. And now he fits the format. So your answer is 4 comes along for the ride. And then the formula says 1 over a. So 1 over 1. Well, 1 over 1 is 1, so I'm not going to waste my time writing it. Times the arctangent of u over a. So u is 6x over a is 1. So 6x plus c, because 6x over 1 is just 6x. Okay, so let's do a couple more. We've got number 3. Says I have the integral of 3 over 49 plus 6 minus x squared dx. So again, without wasting our time, it doesn't fit basic u substitution. It doesn't fit any of that stuff. So I'm going to drift towards inverse trig functions. I notice that there's not a radical, and I notice I've got the sum of squares. So I'm going to drift towards arctangent. So my u squared, u, and du, and then my a squared and my a. So what's your u squared? Your u squared is a 6 minus x squared. So 6 minus x squared. Your a squared is 49. And then just drop it down. So what is your square root of this? It's just a 6 minus x. And then your du is going to be a negative 1 dx. Square root of 49 is 7. Okay, so in this case, I don't need the 3. So I'm going to drop the 3 out front. But I do need a negative. So I'm going to make a negative 1 here and balance with a negative 1. And now I've got everything I need. Okay, so this becomes 3 over negative 1 is a negative 3. Okay, so since I've balanced, everything is there that I need. So what does the formula say? It says 1 over a. So that gives me 1 over 7. Arctangent of u over a, which is 6 minus x, over 7, plus big C. So this, you could rewrite this part as just a negative 3/7, and then finish it out if you want to, whatever makes you happy. All right, so I now have the integral of 9 over the square root of 4 minus x plus 2 squared dx. Okay, so I notice a radical and I notice subtraction. And again, if I go through my little steps, power rule's not going to work, u substitution's not going to work, the derivative of the bottom is not in the top, so it's not the natural log. So I'm going to come over here. I notice I've got a constant squared minus a variable squared. So that's going to be my setup. So I'm going to try and morph this thing into arcsine. So I've got a u squared, I got a u, I got a du, I got an a squared, and I got an a. So my u squared is what is your variable. So he's an x plus 2 squared. My a squared is 4. So then drop it down. This is just x plus 2. This is 2, and this is 1 dx. Well, I have 9 dx. Well, who cares? Look, now the 9's gone. Okay, so now I got everything I need. So the 9 is coming along for the ride. I don't need to balance anything because I got everything I need. And so I'll have 9 times the arc sine of u over a, which is x plus 2 over 2 plus c. And then that's done. All right, so let me try and squish two more in here. I've got the integral of e to the 2x over 9 plus e to the 4x dx. And again, I see the sum of squares. Since my exponents aren't the same, it's not natural log or anything like that. Okay, the derivative of the bottom is not in the top because your exponents don't match. All right, so I'm going to start going towards arctan. So I've got u squared, u, du, a squared, and a. So what is your u squared? It's e to the 4x. What is his square root? So go back to your bases. If your bases match, you add your exponent. So 2x's plus 2x's is 4x's. In other words, e to the 4x's square root is e to the 2x. And then what is his derivative? It's write what's sitting there times the derivative of your exponent. So you'll get a 2 e to the 2x dx. What's your a squared? It's 9. So your a is 3. So do I need to balance anything? I do. I need a 2. So balance with a 1/2. And now you got everything you need. So 1/2. And then the formula is 1 over a. So that's 1/3. Arctangent of u over a, which is e to the 2x over 3. So you can change that into a 1/6 or just leave it like that. I don't care. All right, let's see if I can squish one or two more in here. We've got, oh, this is fun. All right, so we have the integral of negative cosecant cotangent over 49 minus cosecant squared. And so what am I noticing? Well, I notice that I've got the difference of squares, and I'm leading off with an a squared, or a constant squared. So if I try everything else, it's not going to work. So let's see if we can make this into arc sine. So I got an a squared and an a. So what's my u squared? My u squared is cosecant squared x. So what's his square root? It's cosecant x. And then what is the derivative of cosecant? I don't know where it is. It is negative cosecant cotangent, which is exactly what you got. So negative cosecant cotangent. What's your a squared? It's 49. And what's your a? It's 7. So this is completely done. All you have is, there's nothing to even balance. It's completely done. So it's the arc sine of u, which is cosecant, over a, which is 7, plus big C. And then we'll do the last few on another video after I figure out how to